G'day, I'm Greg and welcome to the shed. What am I going to do today? I'm going to start work on making a couple of V-blocks to use on the shaper and generally around the shop. They're only going to be made from a bit of hot rolled, a decent sized bit of hot rolled, but what it will do is it will give you a bit of an idea of what you can do with the shaper. These particular V-blocks, if I'm going to harden them, I'm going to have to add carbon to them. So that might be something else that we do. We might have to do some carburising and some surface hardening, and then we might grind them back. So I'll play around with that idea a bit yet, because this could very quickly become a very, very, very long series without too much trouble at all. So what we'll do is, the first thing we'll do is we'll have a look at the bit of raw material that I'm going to work with. Then we'll have a look at the development of the tool bits, and then we'll set it up in the machine, and then we'll start doing some cutting. We'll square it off, and we'll see how it proceeds from there. And once it's when I say we'll see how it proceeds, once it's squared off, then what we'll do is we'll mark it up and we'll come up with some designs on it. And yeah, it's going to be a bit fluid, is probably a good way of putting it. So we'll see how we go. Let's have a look at the raw material. This is where I like shapers. Well, what we have here is we have a piece of pretty scungy hot roll plate that has been flame cut. And what I've done is I've hopefully you can see that. You can see the flame cut down here. It's quite noticeable on this face here. You can see the discoloration. So it was cut from this side. Let's put it on the way. This is the way it was cut. It was cut here down, and you can see the lay of the flame in it. And you can see on top here, it's just a bit of hot roll with plenty of mill scale on it. On the end here we've got bandsaw cuts. What have we got on the other end? Same, this has been cut with the bandsaw. So this is just a block that is 6, so I turned it over. It's about 6 3/4 inches long, so it's 150, about 185 mil long. It's 75 mil wide. It's 80 mil deep, so it's about 3 1/8 deep and about 3 inches wide. It's high in the centre on that side, and it's sitting on the outside edges on that side, or it's flat, one of the two. But logic would indicate that if it's high here, it's probably low there. It doesn't, on a very quick look with a piece of tool steel, it doesn't look too bad. So either way, that's what we're going to start with. And out of this somehow I'm going to put it in a big V. We'll put it in a little V. We'll probably, you know, traditionally you put a couple of grooves in on the side, and then what we'll do is we'll cut it into half, so it'll make a couple of big V blocks. What I'm actually thinking of doing is this might end up with 4 different size V's in it, or maybe even more, because these faces are big enough. I can have 2 V's in the same face, and because I'm going to cut, what I'll do is I'll cut the whole lot together, and then we'll split it in half afterwards, and so that everything should be consistently good or consistently bad, depending on how it comes out of the machine and how good I am and how enthused I am. This bit of 1 inch tool steel that I've got here, This is the one that came with the machine. At the moment I haven't got any more big lumps of tool steel. Actually what we'll do is you are fully zoomed out. What we'll do is we'll come back a little bit and we'll try and get a bit more of the machine in the picture. So the problem with this big chunk of tool steel is that it's really quite marginal as to how it fits up. It's only just in the bottom, sticking out the bottom of the machine here. So it'll probably be okay. But we'll play around. We'll play around with it. That there's yeah, 4.5 inches long. So certainly anything that's less than 6 inch in this machine is probably a little bit small. So what I've done is I've blackened up this end, and what I'll do is I'll finish putting a bit of black on this end, and then I'll put on some layout lines. Yes, I know I should be using blue, but I might use blue on the other ones. As you can see, I actually like red. I find red is easy for me to see. This is a bit of M42, so it's by memory M42 is about 8% cobalt. This here is what's that one? That's a Sutton Tools. This one here is a piece of P&N, I think it is, Supermax. This here is just high speed steel. In reality it's pretty close to that. This is out of China. This is cheap, and providing I keep my cutting speeds down, it's just ordering high speed steel. It should be quite adequate. It's P&N, sorry. Yeah, that one's P&N. It says so on the packet. Supermax Australia. Yeah, I've already I did a little bit of profiling on that. We'd used that for another job, which you haven't seen. This here is a Union Carbide, I think it is. It's obviously, I'd say it was originally made for a lathe, but we might even give that a bit of a run and see how that goes. It's a lathe tool bit. It's got too much back rake on it. We might flatten that off and take some of the rake off it, do a few bits and pieces. Although with the way this clapper box works, those of you that saw the video of the test run on the machine, the way this clapper box works, we can probably get away with a fair bit for the simple reason there is so much inertia. As long as we keep my cutting speeds up, there's so much inertia in this clapper box that it actually claps without hitting the tool. So that's one thing I've done. I've just cut a bit of 25mm. It was actually a piece of 25mm RHS tube, and I've cut that down because what happens is this 5/8 just sits in it. It just stops it wobbling around a bit. That'll be alright. It's about 1mm too narrow. I might cut another piece and put that on there. But because we're going into a 1-inch void, by putting this in, what it does is it tightens it up a bit. It's not going to add any strength or rigidity to it, that's for sure, but it will tidy it up a little bit. So what I'll do is, the plan for this is, one end's going to be a shear tool, so it's going to, normally you put a 45 degree on it. I might even go a bit more than 45 degrees on this because I'm going to experiment with it a little bit. We might go closer to 60, and then on the other end what I'm going to do is I'll come in with I'll hand grind a radius on it. Oh, sorry, you can't see. I might hand grind I haven't made up my mind whether I'm going to do a radius like this one or whether I'm going to go like that. I must admit that I'm half tempted to go like that, because what it would do then is it will give me a good it'll give me a good dovetail machine, or give me a good edge for cutting the cutting bees and cutting dovetails. So I might do that. I'll think about that while I've got the camera turned off. Now, I've spoken about this book before, which you can find online. Lathe and planer tools. There's a couple of things in here which I'd like to point out. It's a very good old reference book, and it talks about the difference between a lathe and a planer tool. Here we're looking at a lathe tool, 7 degrees, planer tool, 3 degrees. It talks about the shape of your cutting tool. Planer, no rake. Planer and shaper, 6 of one, half a dozen of the other. It talks about the Whitworth design tool holders, and this is something that anyone who uses lathe tools, a lathe tool holder in a shaper, is a very brave individual. It's okay if you're taking very light cuts, but what's relevant here is that when this tool digs in, it sweeps down. So if your ram sags or anything happens, it digs in and your cut gets deeper. The advantage of this type of tool is that when it digs in, what happens? It reduces the cut, it unloads. Very, very important. Now, this here's your shear tool, and direction of travel is this way, and this is your finished surface. So what you're doing is you're pushing your chip off, and when you think about it, that's no different from how your lathe works. It's pushing your chip off in the same direction as a lathe. So here they're talking about lathe tools. Now what they also talk about here is the Whitworth design of lathe tool, which is in reality the same as what we were looking at as on the planer, the shaper planer. So it's old stuff, but if you're working with old stuff, what you've got to remember is that this equipment that we're working with, this was the latest technology. This is years, decades, centuries of experience go into writing these things. It even talks about forging of tools, how to go in and actually make your own tools, the shapes and the profiles you should use. It's a good book. I won't bother going through it all. But actually, I won't bother going through it all. But there are a couple of things in here that talks about how to make profile cutters. Yeah, look, there you go. How to make master former for cutting profile cutters. Yeah, it goes on and on and on. Cutting feeds for old equipment, when you're working with old steels. So yeah, we'll stop and we'll get back to what we were doing, which is marking up some tools. Okay, what am I going to do with this? This end here is going to be the shear tool. So what I'm going to do is I'm going to put a very slight radius in it. I'm probably going to come down a couple of mil, maybe 2.5, 2.5 mil. So that'll be the radius across there, which you probably can't see. So we'll probably do 2 or 2.5 mil through here. I'm going to go pretty much corner to corner across here, maybe not quite. So we're going to be about 55 or 60 degrees. Normally you'd probably go 45, but I'm going to go about 55 or 60 degrees because I want to see how fine a finish I can get. And with the slight radius and the fine finish, this back face is going to have very little to no relief on it. because it's actually going to be the radius is going to give me the clearance. And the actual down here is going to be maybe 5 millimeters, 3/16 of an inch. I might do it a bit more than that. I'm thinking that's probably, it might go 10 mil. Go about 10 mil, so it'll be about 3/8 of an inch thereabouts. We'll come across here. And so what we're going to do is we're going to lose that, we'll lose that. I don't know if you can see that. So we're going to lose 10 mil off here, thereabouts, 10 mil off there. We'll take, you probably won't be able to see it because I can't see it, because the end of this was black before I started. So we're going to take this off through, we're going to lose the bit that's underneath the ruler. So what will be is we'll be left with that, and then we'll have a very slight radius on it. And we'll see how that one goes. Now this one here, what I'll probably do with this is we'll put in, what do we want? Probably go, we'll probably have a hole I might go in this, I've got 2 degrees there, we might put in 5 degrees. So we might go 5 degrees along here. It's just, yeah, we've got a 5 degree line there. And then what we might do is we might go 5. So we'll go 55. Let's go. Just playing around with it a little bit. 90. Let's go. I just got it 10, 20, 30, 40, 50. So that's 55. 55 will come to about there. So what we'll do is we'll lose I can see it, you can't. So what we'll do is we'll put a we'll end up with about a 50 degree angle in here, which you can't see. Maybe you can. So I'm going to have that and that, which that'll make it. That'll be quite a nice angle for cutting the dovetails, and that'll be a dovetail and V cutting. And this one here will be finishing, and we'll probably fix this up. We'll get rid of quite a bit of relief off the back of it. We'll let's go 90, doesn't matter which way we go. It does. That there is 3 degrees. Okay, what I've done is I've set this for about 3 degrees. Remembering that 3 degrees is about the amount of relief we should have. That is excessive. Now, I'm not going to have a go at the guys who sharpen this, because unless you've got a bit of experience with shapers, you sharpen them by what you know, which is lathe tools. because everybody is used to a lathe tool. So obviously there's going to be a fair bit of resharpening going on here. Currently this here is, what's the included angle? The included angle is about 67 degrees. So we're about 67 degrees through there. As a, yeah, we're not far off. We're a little bit tighter down the front. We might be a bit closer to 60 degrees, yeah. What's that work out at? It's about 62. So what we'll probably do with this is I'll flatten this off and I'll resharpen it. There's a big chip in the end here that you can see. So what I'll do is I'll radius that off and I'll resharpen it. And I might use this as my initial roughing tool. Then what I'll do with this is I will what do I mark this in as? Oh, yep. What we'll do is we'll V this one. We'll turn this one into a V-shaped tool for cutting the V's in the V block. And this end here, what I'll do with this one is I'll radius this one off so that it is my finishing tool. It'll be a shear tool. So we'll do that, and I might even give you a look at some of it as I do it.